Okay, so these days you may be hearing about like AI agents, right? So people say that AI agents do this, do that, but what is AI agent? What are AI agent, right? So the foundation starts from the agent to agent communication. Okay, so agent to agent communication is the key. This is the protocol, right? So agent to agent protocols are like standardized communication frameworks that enable AI agents to interact, collaborate, and coordinate with each other autonomously. Think of them as the HTTP of the AI world, just as HTTP-enabled web browsers used to communicate with any web server. So these protocols enable any AI agent to communicate with any other compatible agent, regardless of the underlying framework or the vendor. So what was the key breakthrough? Let's understand that. So, unlike traditional systems where agents are wrapped as simple tools, right? So what used to happen, I'll show you an example in previous. So let's say this is an AI agent, okay? Supposedly, say we are creating an AI agent, writer agent. This is the agent which searches about the topic particularly. And let's say this is a tone setter agent, right? Tone set. Okay. So what used to happen previously is we used to give commands in the knowledge base of the AI that, okay, hey, write AI, when you need some latest up-to-date information. So what you do is you call, we used to put one tool name and we used to say, call this tool. And that tool used to be agent_search. Okay. So what used to happen? It used to call this. And so on, this process used to work, right? But this was one, a big problem, that there is no back and forth communication, right? So what was the key breakthrough in this? Unlike traditional system where agents are wrapped as simple tools, these protocols allow agents to communicate as agents, maintaining their autonomy, reasoning, flow, capabilities, and ability to negotiate complex multi-turn interactions, right? So the problem, what was the problem these protocols solved, right? So before agent-to-agent protocols, AI systems face several critical challenges, right? The silo problem, that is, agents from different vendors couldn't communicate, integration required custom point-to-point solutions, systems became increasingly complex and hard to maintain. The tool wrapping limitation was there. Agents were reduced to simple tool goals, as I demonstrated, losing the negotiation capabilities, their back and forth communication, the thinking. So complex multi-turn interactions became impossible. The full potential of agent reasoning was wasted. And scalability crises were, of course, there. So in that, custom integration don't scale beyond a few agents. Innovation was slow due to bespoke development requirements. And also security became inconsistent across different integrations, right? So let's now move to what's the real world impact. How is it transforming the world? See, consider this practical scenario around enterprise operations. A user requests IT support for a laptop issue, right? So let's say this is an IT support, and here is the user, and they come over here, right? This triggers a series of manual handoffs, right? Help desk, right? Ticket ID and stuff. Help desk, then help desk transfers to the hardware specialist, right? Hardware specialist or hardware guy, right? Then procurement, inventory management, if the product needs to be, for example, procured from the person. So then the other logistics, warehouse, inventory, they're very, very, very big stuff, right? What was the agent-to-agent approach? See, the initial help desk automatically, the initial help desk agent, okay, we replace this with an agent, and it automatically coordinates with the hardware diagnostic agents, procurement agents, and inventory agents through standard protocols. The entire workflow completes autonomously while maintaining audit trails and security, right? So here you see this chart, right? So this is what we are trying to learn. Now let's move to the part 2, that is the 4 major protocols, right? So we need to do the deep technical analysis, and now get your notebooks or your brain charged up. Why? Because now we are gonna deep dive really inside the protocols, right? So there were 4 major protocols for this. 4 protocols are there actually. Okay, so 4 protocols are there, on which the whole AI system right now, the whole AI agentic system relies. The first one is, of course, Google's A2A protocol. Okay, so this is a production ready. Okay, we will discuss in short the status. So production ready, it's production ready with 50+ enterprises partners. Primary use of this is cross-vendor agent collaboration in enterprise environments. If we talk about the technical architecture, so A2A operates on a client-server model. Okay, so what is a client-server model if someone doesn't know? So client-server model is a type of a model in which the systems and the backend logics are mostly on the server side, and the client only uses, and the things get dynamically loaded when the client needs it, right? So what they are using is they are using the JSON RPC, okay, over HTTPS. They are using the JSON RPC 2.0. The protocol implements a sophisticated 4-phase communication cycle. Phase 1 is the agent discovery. Okay, this is the phase 1, that is the agent discovery. First, to identify what are the agents, what agents do we have, right? So this is the agent discovery. Then comes, basically in this what happens is agent publishes agent cards containing the capabilities, endpoints, and security requirements, similar to OpenAI specs, but designed for AI to AI discovery. And it enables dynamically negotiations capability. Then comes the phase 2. What is the phase 2? Phase 2 is authentication. Okay, so in this basically SSO authentication or the guardrails and stuff for the prompt injection and stuff to safeguard the system from that. Then comes the phase 3. Okay, phase 3 is about the message exchange. You see, message exchange. Now, in this message exchange, what happens? Firstly, they are using the JSON RPC. So, and the method they use is message send. Okay, role user, and then they part the text or the the input, the kind, the text. Phase 4 is about the task lifecycle management. Okay, task lifecycle, like how much task has been accomplished, which AI agent has done the task, how much the task has been done. So these are the things which comes. Okay, so what now, right? This is done, but what now? So some advanced features of the agent-to-agent protocol uses server sent events, right, for the real-time updates. And the most boost up of this was it supports multiple content types like text, JSON, files, images. So this was the important thing, and this was a breakthrough by Google. In the multi-model support, they have text, structured data, images, embeddings. This is what makes that special, right? And second comes the second which came was MCP, right? This was the most craziest and top thing in 2024, MCP. Everyone are mad about MCP, that is the Modern Context Protocol. It was by Anthropic. So its status is it is stable, widely adopted. Primary use was connecting individual agents to external tools and data resources, right? So one question for you all, like MCP, right? It's Modern Context Protocol, so you need to create MCP service. Would you all be interested in a, like lovable for MCP, right? Which means that you just write a prompt, what you need MCP for, your MCP get created, right? So will you be interested? Comment down, right? Now, let's come to architecture distinctions. So MCP serves as a complementary role to A2A. While the agent-to-agent enables agent-to-agent communication, MCP more focuses on agent-to-resource connections, right? So agent-to-database, agent-to-API, agent-to-tool. So one of the most popular MCP in the market is the Supabase MCP. So basically all these AI IDEs, right, like Cursor, Windsurf has this MCP for the super base, using which the AI could directly interact with your database, understand your table structure and stuff. So this was MCP. What was the technical implementation? This was a client host server architecture. Host, what does host do? So host coordinate AI integration and security. Client maintains like one-on-one relationship with the servers. Server, it exposes tools, data, and resources. Transport mechanisms, it was using STDO. For the server run as child processes communication via STIN and STIN out. And STBSE, which is server runs a standalone, right? So this was it, okay? Now we talk about ACP, okay? ACP, that is Agent Communication Protocol. This was by IBM Lab, Agent Communication Protocol. This was by IBM. So what's the status? Early adoption phase. Primary uses local first environments and edge computing scenarios, right? So if I talk about, this is going to be vast. So first let's talk about how this is working. How is this working, right? So technical architecture and feature first we'll discuss for this. So it uses standard HTTP methods, like GET, POST, PORT, delete, right? So no special protocols. It works with curl, Postman, web browser. So in the coming days, according to me, it's gonna be more widely adopted. More adopted, I could say, more than the MCPs, because its standard as protocols are there, no special protocols. So it works really good. It was developed as a part of IBM's BEAI platform under Linux Foundation governance. So it also has a multi-model message support, text, structured data, images, embeddings, and it is suitable for the LLMs, vision models, and hybrid systems as well. So this is more going good, right? And it's more gonna be adapted in the future. If we talk about what is the hybrid communication patterns in this? See, asynchronous by default. What does it mean? It means that ideal for long-running tasks. Synchronous support, low latency, right? So what are the features of this? Low latency, first of all, like really good thing. Other thing which we learned, the standard protocols, right? So this really helps for the wide adoption, right? So this is the thing. Architecture pattern. So it is single agent architecture. It has a multi-agent server architecture. It has a distributed multi-server architecture. This is like a very good comprehensive view. So that's why we are not gonna go deep into every kind of the architecture pattern. But if you want a video on that, just let me know and maybe we'll try for it. Then comes Agent Network Protocol. This is known as ANP, Agent Network Protocol. This is ANP. So what's the status? It's currently under the experimental, or we would more say on the paper research phase. Its primary use is decentralized agents networks on the open internet. It's really revolutionary approach, but it looks good on a paper. And for the future discussion, if we talk about, so ANP represents the most ambitious vision, creating a decentralized internet for the agents. Unlike centralized protocols, ANP uses peer-to-peer networking with sophisticated identity and security layers. It has 3-layer architecture. Layer 1 is about the identity and encrypted communication. Layer 2 is about the meta protocol negotiation. Layer 3 is application protocol layer. Right? So it's really under very research phase right now, and not much of a adoption or even the application has been seen till now. What are the advanced capabilities if we talk about? So it has the AI native design, so it's optimized for machine-to-machine communication, natural integration for negotiation, and it has the key revolution that is about the decentralized discovery. No central registry is required, peer-to-peer agent finding mechanisms, and maintains privacy while enabling discovery. So you could say it's more like a Bitcoin, why I'm using Bitcoin. I know, guys, relax. I know crypto, right? It's a blockchain technology, but for those freshmen, I just use the Bitcoin, so you just get the idea. What is this, right? So choosing the right protocol. Now comes, we have studied all the protocols. Now come, what is the right protocol to choose? So agent-to-agent protocol is best for enterprise cross-platform integration. MCPs are best for single agent accessing external resources like your database and stuff. ACP is good and best for the edge computing deployment, simple REST-based integration, local first application, right? It has a standard, all the protocols. It has standard protocols. ANP, it's best for research and experimental projects, more for the decentralized version, AI agents, right? So this was all about this agent-to-agents protocol, which is going on in the world, revolutionary, and things are happening. In the next video, we may implement a walkthrough and build our first A2A agent, right? So just an overview. Every A2A agent start with an agent card, okay? A JSON document describing its capabilities. Then comes the server implementation using the A2A Python SDK or building with fast API. Step 3 is client integration. Then comes the production deployment considerations, right? So this was all about the agent-to-agent protocol. And trust me, guys, it's really gonna revolutionary in the coming future. And this is why we say that agents are really doing the work. Okay, so one of the interesting thing which I want you all to be trying is Google's Opal. Okay, Opal is really a good project, like N10, but N10 is more versatile and many integrations could be done, but Opal is limited to the Google's product. But yeah, the Opal is good. You could have some hands-on over there. So it's really good, you could try that. So for this, we keep it till here. And specifically, if you want to go more deep, I have collected all the resources like the research papers, publications of everything, white papers for this. So you'll find in the description one link, click on that and you'll get the very, very detailed notes version. Okay, I hope you have liked this, right? So yeah, let's keep it till here. Then we maybe meet in the next session and do something crazy, right? Because that's what we are built for, right? So let's keep it here. Bye. Have a good day, everyone. Bye. Keep building, keep shipping.